Okay, we'll
Yeah,
start
Mr.
just
Can
the.
we start? Okay, please let's start. Others will be catching up.
All right, we'll start shortly now. The facilitator will join us now. Okay, Kule, please reach out to Okpeyemi. He was that link, so you need to use this link to join the meeting. I want him to join this meeting. He's using yesterday link to join the meeting. You need to use this new link.
Which of the Okoyemi? I.
Okpeyemi Ogunjimi.
Tope, do you know this person he's talking about? Hello, Tope. Hello, Tope. Can you hear me? Do you know the person he's talking about? Okay. Thank you.
Are we all set now?
I'm off the 11th floor.
Engineer Davidson.
Yeah.
Good morning. Can you hear me? Hi. Good morning. Good morning. Can you hear me?
You can hear you, sir.
Oh, so we are going to continue from yesterday, and I'll just make it faster today so we can continue with. So we can continue with our activity. We're talking about setting out yesterday, and we're doing this part. We're working on this type of scenario. So I need someone to explain how we set out our site for this type of scenario. It is 10 meters by 10 meters. Someone should explain it. We already talked about this yesterday. Let's just start from here and move forward. Who can explain how we do this part, how we set out the site? Someone should explain now, or I'll just explain and assume everybody understands it. Okay. First is to get your midpoint, the midpoint of the site. Get your midpoint, whichever method you want to use. But the first thing you need to do is to get the midpoint of the site. Call this my midpoint. From your midpoint, you set out your tower foundation. Yeah, tower foundation is 2.2 by. You have like 1.2 in this axis for your tower foundation. Complete your tower foundation setting out with 2.2 by 2.2. So to get your first guide wire point, you are supposed to go 5 meters towards the north. So from the middle of this tower, we'll call it C. Call it point C. From point C, you go 5 meters towards the north. Let's say 5 meters is stopping here. From here to here is 5 meters. 5 meters. So at 5 meters, that's the middle of your guide wire. So from the middle, you can now set out your guide wire foundation. Like I said, that 5 meters is the middle of the guide wire base plate. Guide wire base plate is like this. Guide wire base plate is like this. It's like this shape. And it's like 750 by 750 all around. It is the anchor plate here that connects the iron rod to the. So your guide wire base plate is like this, 750 by 750. So your 5 meter is stopping at this center, the center of the base plate, not at the tip of that base plate. This one is wrong. So at 5 meters, you need to now set out your guide wire base plate. So you'll be having something like this. And for the trench, for working space, it has to be 1.1 meter by 1.1 meter around. So, and we'll call this our guide wire at point A. Who doesn't understand this part? Hello?
Can you come again, please? My network was
Which
breaking.
part? Which part should I start from?
The guide wire part.
You can see this tower foundation. The tower foundation. This is tower foundation. Can you see this tower foundation? Is this part clear?
Your cursor is not moving. We can't even know where you are. Okay.
Writing on the board now, I'm showing you tower foundation. Even without showing you tower foundation on this sketch, you should know which one is the tower foundation.
Yes, okay.
This tower foundation is 2.2 by 2.2. That box, the first red box you are seeing is your tower foundation. And yes, monopole. And how did I get this tower foundation? I just divided my site into two parts and I got the midpoint of that site. From the midpoint of the site, I can take 1.1 up, 1.1 down, or use the diagonal method. You can use the diagonal method to get your diagonals, then box your site. Any method you want to use, get your tower foundation trench. Fine. The major thing is get your box right, 2.2 by 2.2. And if you check again, this box is parallel to the true north. See the true north here. The north is directly in the middle of the tower foundation. Part of the mistake people usually make is they will do something like this. That they confirm this is their true north on site. And they'll get their midpoint. Let's say their midpoint is this part. Then they will still go ahead to do their tower foundation this way. Oh, let's not even use this slanting method. They mark out your sketch like this, normal box, but they're confirming that the true north is this. It's fine, no wahala. But their tower foundation will now be standing this way still. Is this method correct? True north. So you've gone the extra mile to confirm that this is your true north. You've confirmed that part. So why is the foundation? If this is true north, very okay. It means this foundation, this tower foundation should also be like that. So we'll be having something like this. We should be having something like this for our tower foundation. So it means the middle of that foundation must be parallel to the true north also. So if you take this sketch too, you can see the middle of my tower foundation is matching with the true north already established here. That's the first thing you need to note when making your setting out. Then after establishing tower foundation, the next thing you need to do is to establish your guide wire point. And we have 3 guide wire for this tower. The one guide wire at guide wire A is at 0 degrees. Guide wire B is at 120 degrees from 0 degrees. It means you are starting from 0. The first guide wire is directly at 0. The second guide wire is 120 degrees from 0. Then the third guide wire is 240 degrees from 0. That's 3 guide wire we have. So how do you establish this point on your setting out on site? Marking your tower foundation like this. To get this first one, guide wire at 0. To get guide wire at 0, what do you need to do? Someone should explain what you need to do. So which direction? Yes. That's how you get the guide wire at 0. You measure 5 meters from the middle of your tower T towards the north. And this is our measurement. This is our 5 meters. From here to here now is 5 meters. Towards the north, if you check it, you can see it's still parallel to the north. That is your 5 meters. So at that 5 meter point, that's the middle of your guide wire base plate. I said it before, your guide wire base plate is like this. and 750 around. That 5 meter is stopping at this midpoint of this base plate. Can you see where I'm marking as the midpoint of the base plate? That is where that is the exact size of the guide wire. But for the excavation, we excavate more than this. But this is the base plate dimension itself. What I'm showing you is that 5 meter is stopping at the middle of this base plate, not at the edge here. If this you stopping it at the edge here is wrong. This one is wrong. This is correct. So after establishing this 5 meter point, the next thing you need to do is to get your base plate, set out your base plate, the same way you set out your tower foundation, and set out your base plate. You'll be after setting it out, you'll be having something like this. You can see the 5 meter is stopping at the midpoint. That's one thing you need to note. And also the tip of that guide wire, that is the tip of this guide wire here. The tip of the base plate must always touch the 5 meters line on all 3 angles. You need to make sure the tip of that base plate, this tip here, is touching the 5 meter line. So if you look at it from this guide wire at 0, these are 0 degrees. 0 degrees. You see the tip of the base plate is touching the 5 meter line. This dimension, we'll call this dimension 1.1 meter by 1.1 meter. That's your guide wire at points at 0 degrees. That's guide wire at 0 degrees. How do we get the guide wire at 120 degrees? Yes. How do you do it? Yeah, that's correct. This is point A. And it's guide wire at 0. To get point B, I said it yesterday. Someone needs to stand at point A, middle of the base plate, still at the middle. Every dimension we are taking here is from the middle. Someone needs to stand at this middle of point A, this point here. Person needs to stand at the middle of the tower. The guy standing at point A needs to take his tape to 8.66 meters. We'll be having something like this. The guy standing at the middle of tower needs to take his tape to 5 meters. We'll be having something like this. Where the two tape will intersect, this is 8.66 meters. This is 5 meters. Yes. Exactly. That's why it is a triangle method. You are targeting 5 meters. Where the two of them meet, you need to force the two tape to meet. You are not targeting any angle. Your own idea is that I need to make sure these two tapes are meeting. So if you take it upward and your 5 meter cannot reach it, it means you are moving on in the wrong direction. If you take it downward too much and your 5 meter is crossing it too much, you are moving in the wrong direction. Where the tape that's the essence of this method. You are establishing an angle, and now you establish the angle, you need to make sure the two tape meet. Anywhere they meet is your 120 degrees. You understand it? So you take 8.6 meter. Someone standing at point A takes his tape to 8.66 meter. Whichever direction you want to take it to, no wahala. Someone standing at the middle of tower takes his tape to 5 meter. You now need to make sure, it means someone needs to stand at point B and make sure the two tape, pull the two tape together for the two tape to meet at 8.66 and 5 meter. That exact point. It means on that point, you should be seeing 8.66 on one tape and 5 meter on the second tape. Where the two tape meet is your guide wire at point B. And that midpoint, that point is the middle of the base plate. So at that middle, you need to now set out your guide wire base plate. So you can do something like this. Because this is the middle. This is going to be middle. Is this setting out of the base plate of B correct?
Yeah. You don't start again. You don't.
Is this base plate, is it okay? Who can confirm if it's okay or not? We've established point B. Yeah, this red box I just draw at point B. Is this drawing correct or not? Why is it correct? Yes, apart from being at the middle, I also mentioned one other point. It will always be, it will be 5 meters. It's going to be 5 meters, and up will be 8.6 meters because we already measure with the tape. What is wrong with this diagram is I said the tip of the base plate should always touch the 5 meter line. Now look at what I did here before. Look at what I did here before. But in reality, this is how your setting out should look like. Are you seeing the difference? The tip of the base plate, the tip should always touch your 5 meter line. This tip should always touch your 5 meter line.
Okay.
So if you are setting out your base plate at point B, you should be having something like this. I'll call this point B. This is the middle still. 1.1 meter by 1.1 meter. Who does not understand how we get point B? Is point B clear?
Yes, it's clear. It's clear.
So if you have anything on side that can measure this angle for you, you find out that this angle 120 degrees. We check it, you can use it to double confirm what you've done. This angle give you 120 degrees. So, how do we get the third guide wire point? Exactly. So from point A, one person stands at point A, takes his tape to 8.66 meter. Someone stands at the middle of the tower, takes his tape to 5 meter. Force the two tape to intersect. Wherever they intersect is your 120 degrees. So we'll be having something like this. Having 5 meters here. Having 8.66 meters here. Wherever the two tape intersect is your 120 degrees, and that is the middle of the base plate, not the edge. So from that middle, you can now set out your base plate. 0.1 meter, 1.1 meter. Is this base plate correct? How should the base plate be like?
You should touch the 5 meter of the 5 meter.
Exactly. So if you are doing the right setup, this is how your base plate should look like. Tip must always touch the 5 meter line. Then you have your 1.1 meter. This is to the middle. So that is your point C. That's your third guide wire point. And the last thing you need to do to confirm if you've done the right thing or not, the distance from point B to point C, this distance between point B to point C,
How is the morning?
must also give 8.66 meters. This. Come on, sir.
Hello.
You understand it? So you can use this one to cross-check what you've done. If point B to point C is also 8.66 meters, it means setting out is okay. Submit for approval. So that is all about setting out. Who does not have who have any question regarding this? Let's move to the next part. Yeah, we are good to go. Another thing you can do is you might not necessarily make your 10 by 10 plant like this and still have it this way. No, voila. The major thing is you understand. You can still have your side area like this. The issue is you need to make sure your tower is in line with the two nuts. Forget about the sight box. That one is not major issue here. Major issue is aligning your tower, these two nuts. So whether you leave your sight area as normal box or you put it slanty, don't have any issue with that one. So it can be any direction. The sight area can be in any direction, but your tower must be in line with the two nuts. So move after setting out. After this, you can now continue send this for approval. Check and review, then pass. Obviously, when you're sending it over on your QC, you see so many other QC information you need to fill out, like measurements. They need to see your 5 meters measurement. They need to see your 8.6 meters, your tower measurement. After sending all those things, your setting out QC can pass. Then you are supposed to, after setting out, you are supposed to do your excavation for your tower and your guide wire. But before excavation, you must have done your soil test. Without soil test, you're not supposed to start excavation. Excavate without doing soil test, you probably want to do your blinding without doing soil test too, and there will be too many back and forth in the project. So it's better you don't blind excavate without your soil test. You understand it? So you need to do your report before you need to carry out your soil test before you do your excavation, or else you're on your own. Done. So the first thing you're supposed to do normally is you mobilize to your site now and you confirm team is on site. Once you confirm team is on site, you also need to confirm LOS point. You would think this one is not an issue because survey must have been done. But the issue with this is different survey points were picked, and we had like 3 points that were fine for deployment with LOS okay, and we had like maybe 2 points not LOS okay. Sometimes you have misinformation between the SAQ guy and the survey team. SAQ might go and acquire points that are not LOS okay, and if you go there, you think you're on the right spot. You need to confirm that coordinate when you get to site. Once you've confirmed team is on site, You also need to confirm that coordinate, confirm LOS. So when you get to your point, the proposed site location, send that coordinate back to the survey team to confirm that that point is okay for deployment. After they've confirmed that you're on the right spot, then you can start your setting out. If you're not on the right spot, you need to continue your journey to the right location. After setting out, you're supposed to now do your soil test. Then, after soil test is confirmed pass, you're supposed to commence your excavation. And when doing your soil test, what you need to note is that soil test has to be sealed with current. There's no current stamp on that soil test report. Rejected. After your soil test with your current stamp, we'll upload on ISDP, then you start your excavation. And for excavation, our foundation is supposed to be 2.2 by 2.2 by 2.2 by 1.55. All these are in meters. Then your guide wire foundation is supposed to be 1.1 by 1.1 by 2 meters. These are the dimensions you'll be using for your foundation. So is 2.2 by 2.2 by 1. Your guide is 1. Land is relatively flat. If it's not flat, it means you need to probably establish a benchmark and modify your excavation depth. If your ground is slopy like this, what is going to change is the width and the length will still remain the same. What is going to change is the depth. Understand? If you are on boss. Yeah. Yes. Okay, I'm coming. 7th floor. Yes, I know. Okay. So if the site is not relatively flat, what is only going to change is your depth. So your depth might be maybe 1.5. So 1.55, you'll be having 1.5 or 1.45, depending on the terrain. But if relatively flat, this tower dimension must still remain the same. 2.2 by 2.2 by 1.55 meters, while your guide wire foundation should be 1.1 by 1.1 by 2 meters. After excavation, you take your information on QC and upload for approval. Then you can, once it's closed, you can commence your foundation blinding. You only be blinding the tower foundation. So after excavation is closed, you commence your blinding, and your blinding is going to be 50 mm thick.
This one with this man start with drawing on the board.
And you'll be blinding for only your tower foundation. Your guide wire foundation do not need blinding. You understand? So you blind only tower foundation to a thickness of 50 mm. Then upload on QC for approval. Once it's closed for approval, use tower foundation installation. For the foundation installation, I'm going to send you a sample photo so you understand how you couple your foundation. Normally, SC is supposed to be on site for this activity. Let me share my screen.
Don't align with Joseph. Yeah. Don't die. I don't know it's the one person to say so. Bukola they give score there. I'll take consignment. Timo,
My name.
what's good?
Jojo Sky.
How are you? Sorry. Oh, yes.
I want
Don't want to.
I can't see I give a leg. I mean,
No, I want to show you the foundation.
So they all start and so it's why is going to put it for corporate? Sky section. Why don't they put it for corporate? Maybe.
So this is how your 2 hour base is going to look like, basically. You can just watch. Analyze it before GSC to review. So that's what this person is doing. Once it's done, I'll show you the overview of the foundation. And you can see the marking. This is number 3. Then obviously number 4. All the nuts must be completely installed. There must not be any vacant space for any nuts. Make a detailed video like this. Show your level gauge, because you need to check the horizontal and vertical level for backfilling. For making detailed video showing all these bolt and nut connection, you need to also make your level gauge video too. So I'm going to exit this one and show you the general view. So this is how the foundation is going to look like. So you can take a photo of it. When they're installing, the objective is to install and have something like this. You understand it? Check all your diagonal braces here. All your diagonal braces are the block nut. All around. So if this is not done like this, GS is not going to pass your QC. Who have any question regarding this part? Then move to the next part. Give me feedback. Let me move to the next part. So after the foundation installation, there needs to be a confirmation for it. Someone needs to confirm it for you. Apart from uploading your videos, someone needs to confirm on site, and that's supposed to be the site engineer. But if the engineer is on site, you can just send your video to me on WhatsApp to help you check and confirm. You can move forward. After your confirmation is done and your QC is closed, you can start your backfilling. For the backfilling is the requirement is still the same requirement. If you've done any kind of backfilling before, the requirement is still the same. It's not going to change. So we are going to backfill in layers of 200 mm. And you'll be using a jumper compactor for your compaction. Layers of 200 mm, then a jumper compactor for your compaction. That's the backfilling requirement. So it means for your tower foundation, your tower foundation is like this. You install your tower foundation in a trench, and you want to start your backfilling. Because of this base plate here, the first layer can be 400 mm. It can be 400 mm. But after this first layer, the next layer has to be 200. So you keep on doing like that until you get to your final elevation. For each layer you backfill, you need to compact. For the next layer, you compact with your jumper compactor. Fill it with water. Backfill the next layer, you compact, fill tight, keep on that you get your layer. When making video for this compaction, there's no point recording a video when the soil is not properly compacted. So your video should start when that layer has been compacted. So it means if you are going to be spending maybe 5 minutes on compaction of each layer, you don't need to start your video at minute 1 or the first few seconds to start compaction. At that point, the soil is still very, very loose. Your video should be starting at maybe 4 minutes when the compaction is almost done and all that layer is completely locked. Who doesn't understand this part? Who doesn't understand this part? Okay. So I'm going to pause now. I need to attend to something. I'll come back like 5 minutes.
We can hear you speak, Davidson.
Okay. So donor side visibility then? Yes. Donor side visibility then?
Davidson.
Okay, good. And
Okay, all right. Let me just hold up for you.
So it will be using this normal laptop method back. That meeting room is occupied already, and the to open a site, a typical site that have like enough information that we can use. Can you see the screen? My speaker is not working or what? Can we see the screen? I can get feedback and tell them. Yeah, so after foundation installation, just like this, you need to send for approval. And this was the level check I was referring to. Your level, while the side, the vertical level has to be checked, even though this one is almost not level. I don't know why I was lucky enough to get it passed, but you need to check your level, your base level too. Make sure it's checked, so your tower will not be shifting to one side. After uploading all this, you send for approval, then you can commence your backfilling. And we already established the guide wire points ABC, and we've excavated them. I mentioned the excavation depth for those guide wire. Who can remind us the excavation depth for the guide wire? Yeah. So after excavating that depth, I said it, we don't need blinding. So you are just supposed to install your base plate directly in the trench. So you'll be having something like this. You'll be having something like this. These are the base plates, and you need to label for GSA to see. And when installing these base plates, there's some information you need to note. Your earthing flat bar must be terminated to the base plate. You can see this earthing flat bar here. This is the earthing flat bar. Then you also need to show the You also need to show this U-bolt connection to the flange to show you've locked it, and this iron rod is properly connected to the U-bolt. You need to show this connection point. You need to show this base plate termination. And last thing we also need to note here is that this iron rod here, the iron rod you are seeing here, normally based on standard, this iron rod should be parallel to the tip of this installation is not 100% perfect. This base plate is supposed to be rotated towards, like, let me explain what I'm saying. You see this trench and this tip must align. So the base plate needed small rotation to the right a little bit, so that the tip of this, and I was mentioning the tip, because the tip of the base plate must always be in line with the 5-meter line. And it means this iron rod also, this iron rod you are seeing here, normally should pass through the tip of the base plate. This iron rod should be positioned this way. If this base plate was perfect, this iron rod should have passed through this point. So we are supposed to be having something like this for the iron rod. So maybe it was adjusted before backfilling. I can't tell, because this is just a random photo. But the idea is the iron rod should pass through the tip of the base plate. And also that base plate should be in line with the 5-meter line. With this, you'll be having perfect alignment on your guide wires. Who does not understand it? Yes. Yeah. Yeah. Yes. 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 No, the rod is going to be connected to the guide wire that will be connected to it. That's what I'm saying now. That's what I'm saying. The base plate should have been rotated. You need to rotate it a bit. Yes, that's the correction that this person should have done. Maybe he did it before he backfill. Nobody can tell. But from this picture, this base plate needed a little rotation to make it aligned. And again, we also cannot tell if his excavation is correct. Maybe this tip is actually his 5-meter line. Maybe it's the excavation that is having issue. Nobody knows. But if you are working on site, you know what you set out. You know where your alignment is. How do you know? No, how do you know the edge is correct? Is the question. Now Aboki excavate all these pits. How do we know they maintain the same edge? No, from the picture, you are using the picture to judge. Picture excavation can also be wrong. What I'm saying is, you, the engineer on site, you know what you set out. You are the only one that can say this is where my alignment is. So if I see this picture, if I see this picture, if I see this picture, I can query the guy, and the guy can be like, no, this is where the issue is. This excavation is not. He can even go ahead to make video for me and show me his alignment from the middle of the tower coming to this guide wire trench, and show that his excavation is already shifting towards away from the 5-meter. If the person knows what he's doing, he can make video to tell me that, boss, that base plate installation is actually where my alignment is. Is my excavation that have issue? Or maybe, okay, yes, if true, this excavation is correct, I will need to rotate my base plate a little bit. Any solution is fine, because you on site know what you set out, and you know where your alignment is passing to. Because at the end of the day, if there's issue with your alignment, you will install it back again. It's not me that will come and help you to install. You need to decommission what you've. So if anybody sees an issue, excavation that is no, forget that can have small issue. Focus on the base plate should have been rotated to the right a little bit for us to have something like this. For us to have something like this is how that base plate should have been. If I'm judging based on picture, that base plate should be like this. You understand it? It should have been shifted to the right a little bit, but we never can tell. The person that installed has the only answer to the question. But what we're explaining is the base plate installation. So you can label these base plates ABC, because you have three for you to know you took different photos for your base plate. Then after that has been confirmed, you can commence your guide wire backfilling also. The same way you are backfilling your tower, you can backfill your guide wire trench. And for guide wire backfilling, because compacting machine cannot enter at 2-meter depth, you can use manual compaction for that part. You can use manual compaction till where you get to a level where you can insert your compacting machine to work on. And for guide wire compaction, we also maintain the 200 mm layer. You use manual compaction to maybe you get to 1.5 meter height. So the remaining 500 can be done with your compacting machine. You understand it? Your manual compaction, because you are using manual compaction, does not mean you will now stop the water process. Once you finish with manual compaction, you pour water in the trench, then continue the manual compaction again. You pour water just like this. See how this person is filling after compaction, after compacting layer, you fill it with water, then compact the next layer. After you finish backfilling your guide wire, then you finish backfilling guide wire and you finish backfilling tower. There is something this guy is missing. I don't understand how they sneaked and passed this QC for him without uploading that part. There's an angle here. There's an angle we are supposed to pay attention to. there be adjustments within that axis?
Because the excavation is having, there is a little issue in the excavation.
No, nobody.
That is why the iron from the distance is not
I'm
straight.
not talking about the straightness of this iron. Let me show you. Let me show you the design. Maybe you understand what I'm saying. See this picture. See this base plate. My question is, why is this iron coming from the base plate? This particular iron. Why is it left at this position where it is? Why can't we install this way? Why can't we install this way? Or this way? Why are we leaving it? How do we know this point? Exactly. So I know I mentioned the question give you. So I'm just bitching about the book for it to interpret what I'm saying. How do you establish this angle where this iron is staying? No. That's not the answer. Your base plate angle. Let me go back to this other picture. If you are mentioning angle, let me now give you a scenario. This angle you are seeing here is also the 5-meter line. I can decide of me brazing this iron rod. I can decide to remove the brace. What I'm saying is I can decide to remove the brace and let the iron stand freely on its own along that 5-meter line. I can decide to remove this bracing on it. This bracing I'm using to brace it. I can decide to remove it and let the iron stay freely and let gravity act on the iron and let it stay freely on the 5-meter line. It will see 5-meter line, but it will be resting on the ground. It will be resting directly on the ground on that same 5-meter line. Because when gravity acts on this iron rod, now if you remove this bracing, the iron rod will fall down and it will be resting directly on the ground. It will be resting like this. The iron rod will now, if I remove that bracing, the iron rod will be like this. It will still be on the same 5-meter line. See, it will still pass through the tip of the excavation. It will still be on the same 5-meter line, but it will be on the ground. How do I know where to push it? How do I know the level to adjust the guide where the iron rod is my question. Mm. The simple answer to this question is the design gave an inclination angle for this guy. If this is my ground level, the design stated clearly that this angle here, the angle between the iron rod and the ground should be 70 degrees. And that's what they call the inclination angle. Your guide wire are aligned at an angle to the tower. That angle is the inclination angle, and the design has stated it should be 70 degrees from the iron rod to the ground level. So now the question is, how do you establish 70 degrees on site? And that is where you need to use this solution. And the solution is from the tip of this guide wire, like this. That solution. From this guy, then give you a short solution to save issues that will be working. From the tip of this ground, leave it at 1.2 meters. From the tip of this guy to the ground, leave it at 1.2 meters and in alignment with the 5-meter line. That is with the tip of the excavation and with the tip of the base plate. Once the iron rod is now at 1.2 meter height from ground level, brace it there and backfill. Understand it. Before backfilling, this one is before backfilling, no, because if you backfill, you can't. Yes. Yes. Brace it, hold it, pin it down at that 1.2 meter and backfill. Even when backfilling, go back to confirm it. So that is what you use to establish your inclination angle for this part. And then you can also see it in this picture. If you check this picture too, it means if I go to this site and I measure from here to this point, if I measure from here to the ground, I should be having 1.2 meter. That's the summary. If I go to this side and I just carry my tape and measure from here to here, and 1.2 meters should be confirmed. Now you get your inclination angle of those guide wire to the tower. Then you backfill. You backfill the trench. It's same backfilling in layers. Same backfilling in layers and with your water. Then we know we're done with this. For you to do your earthing is what you have here. So the next activity is earthing. For our earthing is going to be like a ring connection, and the ring is going to go around from the center of the tower. You go So basically, we're just having like 6 by 6 meter from the multi-man distraction now. Ring around the tower. Let's say your tower is like this. Let me use this picture for example now. This is the tower. Well, this picture cannot work. Check out. So for the earthing, this is the earthing layout. And like I said, it's 6 by 6 meter ring around the tower. So you have like a 6 by 6 meter ring around the tower. If you're having 6 by 6 meter ring from the tower, from the middle of the tower to the edge is how many meters? What should be this distance?
12 meters.
Eh? If the ring is 6 by 6 around the tower, what is this distance? This distance A. This distance A will be how many meters? If the earthing ring is 6 by 6, earthing ring is 6 by 6, what is distance A from the center of the tower? Eh? Why is it going to be 5 meters? I'm talking, you see my A. My A is stopping at the earthing ring. See A here. See guide wire I see at the top part. See guide wire up here. This is my earthing ring. I said the earthing ring should be excavated around the tower area. And the earthing dimension is 6 meter by 6 meter. Then I'm asking, if you want to establish 6 meter by 6 meter, from the center of the tower to the edge of the earthing ring should be how many meters? What is A
It should
supposed
be
to
3
be?
meters.
That's the answer. 3 meters. It means from the center of the tower, you go 3 meter up. You also go 3 meter down to establish the extent where your earthing will be installed. This one is also 3 meters. So from there also, you can measure that forward. The idea is for you to just establish your earthing ring. Once you establish your 6 by 6 around the tower, you can start your excavation. And your excavation is just going to be, you're excavating maybe 300 mm width and 700 mm depth for the flat bar to pass. So at the edge of each guide, at the edge of the earthing pit or earthing ring of 6 by 6, you're having galvanized angle rod installed at point 1. At the 4 corners, you're having angle rods installed. Those angle rods should be driven into the ground. So after excavating 700 mm depth for your earthing around the 6 by 6 trench, Install your earthing rod at the furnace and drive them into the ground. 700, 0.7 meter. Yeah. So at that earthing bar you will attach to the flat bar to the base plate at 2 meter. That flat bar has to come up to the ground and connect to this ring. So if you look at it from this picture, look at the flat bar here. Look at the other flat bar here. Look at the other flat bar here. So they need to come out of the ground from the 2 meter where you install them and connect to the earth. You can see their connection points. So the ring also needs to fit the tower leg. You need to connect to the ring and terminate it on the tower leg for it to complete your earthing installation. So something like this. This is the flat bar installation. This is the flat bar installation. This is the iron angle rod that is being driven into the ground. This one is measuring the length of the trench.
6 meters.
To drive it into the ground like that. Then after the earthing is installed, you can commence your backfilling. If all the earthing system has been installed and the bolts and nuts have been connected, you can commence your backfilling of what you've excavated and run your earthing test. For your earthing test, you'll be testing at least 3 points should be tested. So for the point testing, you'll be testing the tower leg, you'll be testing your cabinet bus bar, and you'll be testing the earthing ring. You can pick a point on the ring and test for it to confirm your earthing values and the value we're So after the earthing, we move to the tower erection. For the tower erection, before you install the first leg, you need to check the before you install your first leg, you need to check the base plate, check the foundation base plate again and confirm its level before landing your first leg. And when landing the first leg, you need to make sure so many escalations like this. So for a tower erection, before installing the base plate, the first leg, you need to confirm the base plate level, just like this first picture. Then there's one that needs to face the south. You need to pay attention to it when installing. This hole has to face the south. Can you see this hole? In south. After this tower erection, I will end this meeting. I have so many work that is pending on me. This hole has to face south. You need to pay attention. If this hole does not face south, your solar will not face south, and you need to install it again. Dismantle the tower and start afresh. So the rigger has to pay attention to this when installing. The south hole, that hole has to face south. Then the tower level has to be checked. The verticality level of the tower has to be checked. Has to be checked. Each section has to be checked, and the lock nut on the base on the first leg has to be installed and tightened. Then you continue other sections like that until you get to your final section. Continue each section one by one until you get to the final section. Then make sure all your nuts are installed. No one should be missing or not installed. If there's any issue on the tower, you'll be responsible for it. Then for your after tower erection, you are supposed to install your solar structure. Solar structure. You are supposed to install your solar structure like this. And for solar structure installation, you can install the diagonals first. Install the diagonals like the beam. Install sides first, then install the beam second. Install these two side beams second, then install the sub-rail last. When installing the sub-rail, when installing the sub-rail, you need to make sure this part of the steel, this C channel. You need to make sure this part. You can see this sub-rail as the face has one part that enter inside like this. Can you see this face? This face on the sub-rail at the top. This face has to face north. It has to face north. It's very, very important. This face has to face north. It means the sub-rail has two faces. One face is flat, one face is chamfered inside. That face that is inside has to face north like this. If it does not face north, then you install it again. All the at the top, they are faced. Yes. No, this direction is not for the tilting of your panel. This direction is to make sure the sub-rail are not installed at the edge of the beam. If it does not face north, this last sub-rail here, this last sub-rail will be installed at the edge here. If you let it to face south, if you are letting it to face out like this, if you want this sub-rail to face south like this, you'll be having something like this. It will be installed at the edge. It means you will not be installed it at the edge, which is not safe. So it means we want all the sub-rail. Yeah, we want all the sub-rail like this to face north. All the sub-rail, the chamfer part of the sub-rail, they should face north. So that's it for the solar installation. Then you can tighten all your bolts. The next part is your guide wire. For the guide wire installation, let me quickly play this video. Can everybody see this video? Yeah, so we need to watch on how the guide wire will be installed. We have the upper connector that connects the tower directly, then the bottom connector that connects the iron rod coming from the base plate. So this is the upper connector that is going to the tower. Mm. They just install the tower like that.
They did.
Yes.
They did.
Yes.
No. Talk by they did. They did. I can share the one we did in Kaduna. I can share the video to you. Around 2022, if I'm not mistaken, or 2021 from 2022. Because the one that they did at Ikara. Because if they did not supply this, okay, they supply those ones that I'm talking about. They use those tall cabinets. They use those tall cabinets. They supply this, unless they did not supply to your side. I did not.
So it means you got to install. You've given not incomplete installation? That site you did.
Yes, but the structure, the base structure that you just explained is a little bit different from the one we installed.
Maybe it was designed for without guide wire. But this
Mm,
one, watch out to install the guide wires.
yeah. Abinas, can you remember?
So for this, after installing the tower connector, the tower body, after installing this part, there's one thing you need to pay attention here. They need to get the extent where this wire will be connected to this iron rod. That's what they're measuring currently manually like this. You can see they've pulled it. They went to pull it manually to see where the wire will, where the extent, where the length of that wire to stop. I see it's pulling it manually to check where the length should stop. You understand it? No, it's not going to pull. If your material is a material that can achieve compaction, it's not going to pull at that 2 meter. You you tension it now. You tension it. It's just like saying because your tower is not filling, the tower will be shaking. If your backfilling material is a material that can achieve the compaction density, that's laterite. If your material is laterite, then after compaction, if you go back to that site 1 week after, it's digger you use to excavate the material out. If your material is that kind of material, we're not supposed to have issue. But if your material is a loose material and you're using to compact, you're on your own. So you also need to check the kind of material you have on site. If it's not suitable for backfilling, you need to escalate. You understand it? Pay attention to the material. If it's too rocky, if it's stony materials cannot be compacted. There will be too many gaps in between. The compaction will be zero. Fine materials like fine sand cannot be compacted. No matter how you compact it, you won't achieve anything. If you go back tomorrow, you see you shovel to excavate all the sand away. That material cannot be used for compaction. So pay attention to your material. So this guy is pulling this wire manually to get the exact length where the wire should connect to the iron rod. And after getting that length, he reduced it again by a factor. This is just manual installation. So after getting that length, he reduced it by a factor. Just watch. So he has marked the points now. Then he's going to bend the wire. So you can see from this video now, that wire did not get to that connector anymore because of that reduction the guy made. So they're using this wire puller to pull the wire to the connector. So hope you understand this part. And if you check again, you can see the connector is installed at the tip of the U-bolt. Don't pull this thing down. Whatever you are doing, your tension level should be at the tip here, at the tip of the U-bolt, like this. This is the tip I'm referring to. You should drop it there. Don't use your spanner and be adjusting this thing down to go and install here. It's wrong. What we want is for the tension to be achieved at this top. This remaining part at the bottom is for future maintenance. In case in future, if the wires become slack, maybe after 10 years, the maintenance team can go with their spanner and adjust this bolt down, and this thing can drop down and give the wire some little tension again. So your tension should be at the tip. Leave it at the top here. Don't adjust it down anymore. So with this, I'm sure you understand. And the excess
Please,
wire.
are you going to supply? Are you going to? Hello.
Yeah.
Are you going to supply the wire puller
No.
to?
You need to carry it to site.
We need to come with it to site.
Yes.
How can we get it?
You purchase it now. Other IBCs already purchased. You purchase locally or you purchase, just check online and find where to purchase from.
Okay. Oh.
So the excess wire, the wire that will be supplying to your site can be maybe 50-meter length. What you have to do is just divide that wire into 3 equal parts. You don't need to start measure, okay, make I cut 15 meter for guide wire 1. If not, that one is not your headache. Just divide the wire into 3 equal parts. You understand it? Whatever quantity is supplied to you, divide it into 3 equal parts and cut it into 3 equal parts. And when cutting, the tip of where you are cutting, you can like tape it with maybe a kind of tape. The essence of taping it is because in future you don't want that wire strand where you cut the wire out to be losing. Once it becomes loose, the wire will start detangling, and the strands will not be good anymore. So you can just tape that mouth, tape it properly so it won't get loose in future. And the excess, you can tie the excess, wrap it, and keep it at the top of the wire like this. Like you can see at the top here, you can see how they wrap some excess around here. You can see it's excess that they wrap, see it's excess too that they wrapped. So wrap your excess and clip it to the wire. You don't need to cut the excess, leave the excess there on the wire. Just wrap it, tidy it up. So that's for the guide wire installation, right? So far, who has any question? Who has any questions so far? So if there's no question, we'll move to the next part. The next part is your bracket installation. For your bracket, the only mistakes I've seen people make is when they're installing their power cabinet bracket. The standard way to install a power cabinet bracket is this way. Also, when installing your batteries, make sure you space your batteries like this. Don't install it together. So for power cabinet, we're using this method of installation. The power cabinet is a three-way bracket, and the three-way bracket should be installed from the solar flange that is connecting to the solar structure from the tower. Measure 500 mm down. At that point, that's where the first bracket should be installed. From the first bracket, measure another 500 mm down. At that point is where the second bracket should be installed. Then you can install your pole. You can install your pole, then mount your cabinet on it. It does not really matter. You just need to understand how these brackets are being installed. 500 mm from the solar connector flange down to 500 mm. That's the first bracket. Then the The second bracket should be installed from that same 500 mm to the second bracket. Disturbing me on WhatsApp. So for that, for the power cabinet bracket, the next activity is your brick wall installation. So for I think we need to end this meeting. I don't want to delay people and keep you here for nothing. I have so many things I need to attend to now. I think what is remaining is just the block work. The block work is not a major challenge. That one is easy. So if you have any question regarding what we've discussed, just ask so I can just end the meeting. Okay. Okay. All right. Thank you.
All right, thank you very much, Davidson, Engineer Davidson. Thank you. We appreciate your time and the knowledge you've impacted onto us. We are grateful. And if we have any question as time goes on, we can always reach out to our PM. And they also reach out to the people that can answer those questions. And the slide will be shared according to our request. I want to thank everyone else once more for joining the call. And yeah, Davidson, thank you very much.
Yeah, no.
Appreciate your time.
Thank you.
Tokbe and Kunle, we thank you for bringing you guys on once more. So we hope to see you guys shortly. Thank you, and do have a good day, everyone.
But this one is right, so we need to install more.